Hey guys, how you doing? It's Mr. Chavla, and in this video I'm going over the part 2 key for the January 2017 Common Core Algebra 2 exam. Now I went over part 1 in a series of previous videos, so this video will be dedicated. It's going to be for part 2. So it's the part 2 key. And that's numbers 25 to 32, the 2-point short answer version, right? And again, this is Mr. Chavla or Mr. C. All right, let's get started. Number 25. I don't need to hear myself like that. Okay, so 25. Express 1 minus I cubed in a plus bi form. So since it's a short answer question and it's not multiple choice, you have to show some work, all right? So first thing, 1 minus I cubed is the same as 1 minus I times itself 3 times. And I'm going to use a different color for the third one. You'll see why in a second. Let's just multiply 1 minus I by itself one time first, right? The ones that are in black. By first distributing the 1. If I distribute the 1, I'll write it out. If you know the shortcut for squaring a binomial, that's better. But this is the one that I just distributed, okay, over 1 minus I. Or I'll just do it like this. I'm just distributing it, right? And then I'm going to distribute the, I'll use green, negative I. So this becomes minus I times 1 minus I, right? And then so this is all going to be in one set of parentheses, because that's the 1 minus I squared, right? And then I had the other 1 minus I, which I'm going to deal with in the end. Okay? So that's the first part. Here we go. That way I could still stay here. Okay, so now if I distribute, guys, 1 times 1 minus I is just 1 minus I. If I distribute the negative I, it becomes negative I again, plus I squared. Now, you didn't have to separate them the way I did. I kind of did reverse factor by grouping. Instead of factor by grouping, it's like in the opposite order to multiply polynomials. You could have distributed using FOIL or anything else, or the shortcut for squaring a binomial. But we got this for now, right? And I'll bring down this 1 minus I, which was in blue, right? Okay, so that 1 minus I was supposed to be in blue, but it's okay now, because now, in the first set of parentheses, this is 1 stays as 1. Negative I minus I is the same as negative 1I minus 1. I becomes negative 2I. I square is negative 1. It becomes plus negative 1, all times 1 minus I. 1 plus negative 1 is the same as 1 minus 1, which is 0. 0 minus 2I is just negative 2I. So I'm going to end up distributing negative 2I. Let me neaten that out a little bit. And I don't need the parentheses anymore. For the left-hand side. So this just becomes negative 2I times 1 minus I. Now if I distribute the negative 2I, that becomes negative 2I plus 2I squared. Now since I squared is negative 1, that becomes negative 2I plus 2 times negative 1. Which becomes negative 2I minus 2. But in a plus bi form, we write the negative 2 first, then we write minus 2I. And here's our final answer. Let's make sure we answered it. So it said to express, I'm going to minimize me for now. Express 1 minus I cubed in a plus bi form. So in a plus bi form, it's negative 2 minus 2I. Now, if you have the Casio, I don't know about the other calculators, you could, if it's in complex mode, you could just enter this in the calculator, but you still have to show work. But I'm going to go into this calculator right here. It's the Symbol Lab, and enter 1 minus I cubed, go. Just to confirm we got the right answer, right? Okay, so 1 minus I cubed is equal to negative 2 minus 2I, right? And there we go. Negative 2 minus 2I, which is exactly what we got. All right, so that's it. That's it for number 25. Express in a plus bi form when we have 1 minus I cubed and we get negative 2 minus 2i, and that's all there was to it. Number 26. An orange juice processing plant receives a truckload of oranges. I'm going to highlight that in blue. So an orange juice processing plant receives a truckload of oranges. The quality control team randomly selects 3 pails of oranges, each containing 50 oranges, from the truckload. Identify the sample and the population in the given scenario. So guys, the sample is the part that we took out from the population. The population is the entire, is everything that's being studied, right? Or everything that we could have looked at. So the population is just all the oranges in the truckload, because that's what they got, right? The processing plant, the orange juice processing plant, received an entire truckload of oranges. So the truckload of oranges, or all the oranges in the truckload, make up the entire population. Right? The part of the population that was selected for the study is the sample, right? So identify the population we did. The sample is just the 3 pails of oranges. So there are 3 pails of oranges, each contain 50, right? So this is a pail, and there are 50 oranges in each pail. I should have just written 50. That's 150 oranges altogether, right? So it's just the oranges in the 3 pails, or the 3 pails of oranges. Okay, so identify the sample and the population in the given scenario. The sample is the oranges in the 3 pails. The population is the truckload of oranges, okay? Now the next part of the question is just to state one conclusion, that the quality control team, remember the quality control team is the one that randomly chose the 3 pails of oranges, the sample. So state one conclusion that the quality control team could make about the population if 5% of the sample was found to be unsatisfactory. So if 5% of the sample, meaning in the 3 pails, 5% of the oranges were found to be unsatisfactory, then in the population, what we could say is that it is likely that approximately, because we don't know for sure or exactly, 5% of all oranges in the truckload, right? Remember, that is the population. Are unsatisfactory, because we use the results of the sample unsatisfactory. We use the results of the sample to make predictions about the population, right? And the fact that the oranges, I was about to say apples, the fact that the oranges were selected randomly means there was less bias, right? So state one conclusion that the quality control team could make about the population if 5% of the sample was unsatisfactory. Well, the one conclusion is that it is likely that approximately 5% of all oranges in the truckload, that's the population, are unsatisfactory. That's the conclusion that could be made about the population if 5% of the sample was found to be unsatisfactory. All right? There were other ones too, but I felt that was like the most straightforward one. Okay, so that was it for number 26. It's just knowing how to use a sample to predict properties of the population and identifying sample and population, right? And the important thing was that it was randomly selected. Otherwise, it would be harder to make a prediction. Moving on to 27. Wow, that's a lot of space here. You don't need all that. Using the unit circle below, explain why cosecant theta is equal to 1 over y. If you know your trig, guys, it won't be difficult. So first thing is you need to understand what a unit circle is. A unit circle has a radius of 1 and a center at the origin, which is the point 0, 0. So let's just label that right here. So here's the center, because it said the unit circle below. And our radius is just the distance from the center to a point on the circle. So this one has a radius of 1, right? And you see how here it says that we have the point 1, 0 as well, because the radius is 1. So now, it's saying to use that unit circle to explain why cosecant theta is equal to 1 over y. One thing you want to make sure you understand, guys, there were a few ways to do this, but the quickest way is if you understand the trig properties and you understand the properties of the unit circle, right? So first thing is, by definition, I'm going to see if I could fit everything here. No, I won't be able to do that. I'm sorry, guys. So it's saying to use the unit circle to explain why cosecant theta is equal to 1 over y. So first thing, by definition, it doesn't matter like whether you're on the unit circle or not. Cosecant theta is always equal to 1 over sine theta. All right? Now, for any point x comma y on the unit circle, which means it has center at the origin and radius 1, right? The x value is equal to cosine theta when you have an angle of rotation, right? The y value is equal to sine theta. So the y coordinate of the point equals sine theta, right? So now, we already know that cosecant theta is always equal to 1 over sine theta, right? So since y equals sine theta and we could substitute y for sine theta in the equation, cosecant theta equals 1 over sine theta. Let me fix that. I don't like the way that's coming out. I don't want it to look like something else. So theta, there we go. So we could substitute y for sine theta in the equation cosecant theta equals 1 over sine theta to get cosecant theta equals 1 over y on the unit circle. All right? So it wasn't a lot. As long as you understand what cosecant theta is, and this is what we got, okay? So it said to, using the unit circle, explain why cosecant theta is equal to 1 over y. Well, we explained why cosecant theta equals 1 over y on this unit circle, all right? So that was all there was to it, guys. Moving on to the next question. The function m of t represents the mass of radium over time t in years. So m of t is the mass, they didn't say what units they're using, of the radium, and t is the time in years. So m of t is the mass after t years. Determine if the function m of t represents growth or decay, and explain your reasoning. Guys, this is not a hard thing to do. There was one of the things we could do is we could look at the form of the function. One of the things, honestly, using the calculator, see if it increases or decreases. But we see it's an exponential function. If you remember from, if you looked at the video, I'm gonna go back up for a second because I want to make sure you guys understand this, because this will help you like really increase your understanding of math and like how to solve these problems with greater ease. If we look at number 2, which we did in a previous video, it said that a rabbit population doubles every 4 weeks. So if it's every 4 weeks and t was the number of weeks, it's not 2 to the t power, it's 2 to the t over 4. and there are currently 5 rabbits in a restricted area. So we started with 5, then we get P of t is the population after t weeks is equal to 5 times 2 to the t over 4. So if t was weeks, this means once every 4 weeks. If t was years, it would mean that it doubles every 4 years. Let's use that same fact to just find out what's happening in this other function, right? Because what I'm looking at, guys, is I got e and natural log. E and natural log are inverse of each other, so they're going to cancel out. So here's what I mean. I could quickly rewrite this function. So I'm going to take out my highlighter. All right, I'm going to use a really light shade of green. And look at this natural log 1/2, right? We have the 1590 in the denominator and t left in the numerator. So here's what I could write this as. We could write m of t as 100. I could pull that natural log of 1/2 in here, right? All raised to the t over 1590. Remember when it was doubling in the other question every 4 weeks? It was t over 4. P of t equals that. Remember from, I think, one of the earlier questions, the multiple choice question we looked at earlier? So this one, something is happening every 1590 weeks. It's multiplied by e to the natural log 1/2, but not weeks. T is years, right? Every 1590 years, it's multiplied by e to the natural log 1/2. Now, you should be able to know what e to the natural log 1/2 is because they're inverses, but let's say that you didn't, right? E to the natural log of 1/2 is just 0.5, guys, or 1/2. I'm going to put 0.5 because it's easier to write it out. So this becomes m of t equals 100 times either you could say 1/2 or 0.5 or 0.50 to the t over 1590. So it's not doubled every 1590 years. It's cut in half. It's multiplied by half every 1590 years. Or it loses it decays at a rate of 50% every 1590 years, right? So determine which one it represents. I'm going to say that m of t represents exponential decay. I'm going to make it so that there's space, all right? And you could have used your calculator and done it a few other ways, but I felt like this was like kind of an expert way to do it, guys. Like, and I didn't get it this way the first time. After seeing it a few times, I figured it out that way because I was actually looking to see whether it has a half-life, and then I found the half-life was just 1590, and I was like, okay, why? So then writing in terms of the half-life makes it like this. I said, okay, how could we do it from the original equation? But anyway, m of t represents exponential decay I rewrote it. Let's not even write that much. Its equivalent form m of t equals 100 times 1/2 or 0.5 or 0.50 to the t over 1590 means that the radium, it's what's called a half-life, the amount of time it takes to get multiplied by a half, right? Has a half-life of 1590 years. Or you could say, we could say that, right? That's the fast way to say it. Has a half-life of 1590 years. And all that means is that it's multiplied by 1/2 every 1590 years, right? So we could say that it decays by a factor of 1590, by a factor of 1590, by a factor of 0.5 or 1/2 every 1590 years, or it's multiplied by 1/2 every 1590 years. But I don't think we have to go into more detail than that, right? A substance with a half-life means it's decay, right? So we'll just add that to be safe. Or let's just write it out, guys, because let's just even go a little farther and say what that means. I think this would be full credit, but I'm pretty sure. But just in case, let's just say this. In other words, this means that the radium decays, we could say at a rate of 50% every 1,590 years, or we could say that it loses. So let's see how they said it in the first one, right? In the first question here with the rabbit population, they said that it doubles every 4 weeks, right? So we'll just say it's multiplied by 1/2. Or let's even make it simpler. It halves. It gets cut in half. So I wish there was a way to say radium mass is, let's say, reduced by a factor of 1/2, or halved. Every 1,590 years. Okay, this was probably a lot more than you had to say. There were other ways to do it. There are a lot of videos online where people show you other ways that you could do this. You could have used calculator, and I originally did that. You could find out what the common ratio is per year. But I thought that this was kind of cool that we could convert it into the regular half-life formula by just using the inverse relationship between E and the natural log. So, and I didn't see that anyone explain it this way. I kind of discovered it on my own. I don't know if they, I'm pretty sure, I don't know if they did it on purpose or not, but I didn't see this as any of the model response sets. So I thought it was cool. I hope, if this doesn't work, by all means, please use a different method, right? I didn't originally use this one. So determine if it represents growth or decay. M of t represents exponential decay because its equivalent form, written right there, means that the radium has a half-life of 1,590 years. In other words, the radium's mass is reduced by a factor of 1/2 every 1,590 years. All right? So that was one way. You could look at other videos. If you want me to go over it, I'll be more than happy to go over it a different way, but I felt like this was cool. Next question. On the grid below, sketch a cubic polynomial whose zeros are 1, 3, and -2. So I'm going to write that on the side here. X equals 1, x equals 3, x equals -2. So remember, the zeros are just the x-intercepts. Now, it's a little hard for me to get a straight line here because I don't get to have a ruler. So just bear with me, and I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, and I don't have a ruler tool in this, I was going to say in this calculator. In this app, I have that in the smartboard. So I'm going to have a nice straight line for my y-axis. All right, maybe I can make this a little smaller so that I can get the axis grid in a little faster. Okay, that's the best I could do right now. Here's my y-axis, and my x-axis should be somewhere. It doesn't really matter. I like to keep it even, but it doesn't make a difference this time. So I just said to, yeah, don't do this, guys, this scribble scrabble that I'm doing. I'm having a hard time on the notepad. I could just put in a line tool. All right, I'm going to redo the x-axis again. I don't like the way that came out. Whoops. So I'm doing the x-axis again, all right? Okay, so let's get this in. So we got 1. So I'll do it with the same level of precision that I did the y-axis. Yeah, it's not easy to get straight lines when you're using this OneNote because it doesn't allow you to trace so neatly, right? You try to get it as neat as you can. I would suggest just use a ruler. All right, and here we have the x-axis, right? So now, on the grid below, sketch a cubic polynomial. That means degree 3, whose zeros are these ones, right? Zeros are the x-intercepts. So I'm going to label them, guys, and I'll use blue. So the zeros are positive 1, so x equals positive 1, x equals positive 3, and x equals negative 2. Cubic polynomial has to have 3 turning points, right? So what I want is basically something, the graph should look something like this. It's going to go up through this 0. Well, that's one way it could go, right? It has a turning point somewhere. Then it has to come down through this other 0. It turns around again, and I messed it up. Let's say it turns around like kind of sharply over here. And then it has another 0 right here. And that's all we really need to have, guys. It's just a sketch, right? And we put the arrows at the end, and all is well. So let's make sure we got that. So on the grid below, sketch a cubic polynomial. We did. Whose zeros are 1. We got that right here. That's 1. Positive 3. So 1, 2, and 3. So we got 1 and positive 3. And then negative 2. Negative 1, negative 2. That's it. So we sketched a cubic polynomial with the 3 zeros indicated, right, on the grid below. That's it, guys. So that was I felt like a freebie if you know what to do. You just have to understand cubic polynomial means degree 3, which is fine because it has 3 zeros and it has to have 2 turning points. All right, next question. Given the equal terms, the third root of x to the 5th and y to the 5/6 power. So they're equal to each other, right? So there were a few ways we could have done this. But this is what we're starting off with. Determine and state y in terms of x. So guys, one of the ways I could do this is I could rewrite the x to the 5/3 using as a rational exponent, using the fact that the numerator is the exponent and the root or the index is the denominator. So that's a fractional exponent. And this is just y to the 5/6 to stay the same. Now what I could do, guys, that was one way I could do it, right? There are a few ways. I could just raise this to the 6/5 power, the reciprocal, because 5/6 times 6/5 will cancel out to become 1. If I do the same thing here, I multiply the exponents, right? 5 times 6 is 30, 3 times 5 is 15, and 30 divided by 15 is 2. So x squared equals y to the first, right? So our final answer is just y equals x squared. Okay? Nothing too like complicated. So given the equal terms, determine and state y, which we did, in terms of x, which we did. So y equals x squared. That's it. Number 31. The results of a survey of the student body at Central High School about television viewing preferences are shown below. So they interviewed a bunch of students. So the results of a survey of the student body at Central High School about television viewing preferences are shown below. So they surveyed a bunch of, how do I say it? They surveyed some of the student body at the Central High School about their television viewing preferences, and the results of the survey are shown below. So here are the different types of television preferences, right? And then we also got the gender. So they're saying, are the event student is a male and student prefers reality series independent of each other? Justify your answer. So we just want to find out if they're independent or not, and we'll justify our answer to find the result. So one of the things is I'll call M male, M being student is male, and R for reality series. So if M and R are independent, then one of the things we could use is just the conditional probability, right? The probability of male is going to equal, the overall probability of male will be equal to the probability of male given reality series. That's a conditional probability, right? The probability of male is just going to be how many males there are, that's 230, over the total number of people who were surveyed, which is 490. So this is 230 over 490. I'll write this out actually. Probability of male right? And the probability of male given reality series means it's only going to be out of the ones that prefer reality series, the total, so that's out of 180. And out of the ones who prefer reality series, the ones that are also male and prefer reality series, there's 70 of those. So I like the way they broke this table up for us, right? Now, let's see if these are equal. If I convert these to decimals, that's one of the ways I could do it. You'll see they're not equal, but let's just say I do this. So 230 over 490 as a decimal is about 0.4694, right? Point 0.4694. 0.4694. Okay, now the next one was 70 over 180. And you could have simplified those guys as 23 over 49 and 7 over 18. It's about 0.3889, just keeping it the same number of decimal places, 3889. This one, the probability of M given R is about 0.3889. So these are clearly not equal, right? So I'm just going to say not independent since probability of M, which is male, is not equal to the probability of male given reality series, right? If they were independent, the two would have been equal, okay? So it said, are the events male and reality series independent? No, and we justified our answer. They're not independent of each other because of the way we justified that the conditional probability and the overall probability were not the same. So we answered the question, we justified our answer, and here's what we got, all right? You could have used the product test for independence, but I felt like this was a more straightforward way to do it. But the product test was equally good too, okay? So that's what we got. All right, next question. Last one in this video, guys. Part 2 coming to a close. Okay, given that f of x is equal to this quadratic expression, so f of x is our quadratic, and g of x is our linear, right? State the quotient and remainder of f of x, which remember was a quadratic, over g of x, which was our linear, in the form q of x, which just means quotient. Q of x is just talking about quotient, plus r of x, which is remainder, over g of x, which was just our x minus 2. All right, so basically they're just saying to divide it. So we could use long division, or we could use synthetic division. Those were like two ways to do it. I'm going to do long division in case you don't know how to do synthetic division, or I'll do it both ways. So long division, we want to do f of x, which is 3x squared plus 7x minus 20, and we put a long division box, divided by g of x, which is x minus 2. Now what I do is first I have to divide the first term, which is 3x squared, by x to get 3x. Then I distribute the 3x over x minus 2, and I get 3x squared minus 6x. But I have to change the signs to the opposite. So if it was positive 3x squared, since I'm going to subtract, it becomes negative 3x squared, and since it was negative 6x, it becomes positive. So the 3x squares cancel out, and I get 13x minus 20. I bring down the negative 20. I divide again the first term, 13x, by x, and I get positive 13. Now I distribute the 13 over x minus 2 to get 13x minus 26. But since we have to subtract, it changes to negative and positive. 13x's cancel out. Negative 20 plus 26 is 6. So the 6 is the last term. It's positive, so I'll put a plus sign over whatever I was dividing by, which was x minus 2. So here's our final answer right here. So it said to state the quotient and remainder of f of x divided by g of x. So that was the quadratic divided by the linear, in the form q of x, which is our 3x plus 13, plus r of x, the remainder, which is 6, over g of x, which was just our x minus 2. So we did it. Okay, so that was long division. It wasn't that bad. Um, long division works for all the polynomials. Synthetic division, you just have to be a little more careful. Um, I think I'll skip going over it. Pause the video if you need to, guys. This is full credit, and I'll also show you guys how to do it using synthetic division. All right, it's a really nice skill to, but I don't recommend using synthetic division unless the leading coefficient of whatever you're dividing by is 1, which it is, right? So let's do it by synthetic division now. Okay, so pause the video if you need to, and I'm going to do it another way and show you guys how to do it, right? And we won't have to look at it as carefully since we already know what our answer should have been. So in synthetic division, whatever you were dividing by, right, x minus 2, you set it equal to 0, and you find out what x would have to equal. If you add 2 on both sides, you get 2. Synthetic division, I don't know why it's named that, but what you do is you do an upside down division box. This 2 just comes outside over here. The coefficients, you want to make sure, again, whether you're doing long or synthetic division, you want to make sure the exponents decrease by 1 at a time. So it's 2, 1, and then a constant term. So the coefficient of x squared is 3. You write that down. For x, it's 7. And the constant term is negative 20. The first term just comes straight down, and you write it again, okay? And this is called synthetic division. You multiply the 2 by the 3. You just multiply instead of divide, and we get 6. And since it's positive 6, we're going to add. 7 plus 6 is 13, so we add instead of subtracting. Then we go ahead and we multiply again. We multiply the 2 by 13. It turned green because I mixed yellow and blue. So 2 times 13 is 26. And it's positive, so I write plus. If it was negative, I'd do minus. Negative 20 plus 26 is positive 6. This last term right here, the 6, is your remainder. So that since it's positive, I'll put plus instead of minus. The remainder goes over whatever you're dividing by, which was x minus 2. The next one is the constant term. That's 13. And since it's positive, I'll write plus. Each time we add one more number in the exponent of x. So this will be x to the first. Had there been another term, it would have been x squared after that. But since the degree increases by 1 each time, so we get the same answer when we use synthetic division. I didn't say which method to use, so both of those are equally valid, okay? Synthetic division is a little faster when the leading coefficient is 1. Right, so that was it, guys. Let me come say goodbye and wish you luck. We got room here so you could even see the problem. All right. Ooh, looks like my head got chopped off. Guys, thank you so much for coming by here. I really appreciate that you came here and not only look through my video and gave me a chance to kind of help you out and share my perspective. I hope it was useful. But also, I really respect you for putting in the effort to look through the videos and putting in the effort you need to do, right? That shows me that you're committed to your success, and I applaud you for that, okay? Now, if you enjoyed the video, if you found it useful, I would appreciate if you hit like, subscribe. I'd appreciate that very much. If not, that's fine, right? Completely your choice. And if you think it was useful and you think your friends would benefit, please send them over too. I'm just trying to help out as many people as possible. So don't stress out, all right? Do the best you can. If you have any questions, feel free to comment below. Anything you'd like me to do differently, anything of that nature, let me know, all right? Best of luck, guys. Bye for now.